Okay, so we're about a minute ahead, and we're going to go ahead and move on. Our next speaker and our last speaker is Natalie Kerr. And Natalie is an environmental public health scientist at the Illinois State Water Survey. Her current work is on contaminants in well water and risks they pose to rural vulnerable populations. She has an MS in environmental health science. As I mentioned this morning, she's part of our new section, and she's the first environmental health professional we've had on staff in probably 60 years or more. So, with that, she's going to talk about some Legionella work we're doing. And Natalie, take it away.
Hello, everyone. I hope you can hear me all right. As Steve said, my name is Natalie, and I work here at the Illinois State Water Survey with Steve. And today I'm going to talk to you about Legionella in homes with private wells. I'll be presenting on some work that Steve and I have been doing. And then also I'll be sharing on behalf of Jesse Gleason with the New Jersey Department of Health some of the work that they've been doing relating to Legionella in homes as well. So I'll give you guys a little bit of background about Legionella. So it's a bacteria, and we've been talking about a lot of bacteria lately. So it's genus Legionella. It was first identified in 1976. There was an outbreak at an American Legion convention in Philadelphia, and at the time it was this big mystery disease, and people really had no idea what was going on. Eventually, they figured out the specific species that was responsible for this outbreak, and that was Legionella pneumophila. And we now know that that disease is Legionnaire's disease or legionellosis, which is what is caused by Legionella. So there's quite a few different species, and each species has a different serogroup, which is a subgroup. And we're still learning as a scientific community which serogroups of Legionella pneumophila can cause infections. There's a couple that are known to be big contributors, and then the others are still under study. So these guys are ubiquitous in water, so you can find them pretty much everywhere in both natural and constructed environments. They are happy to grow at temperatures between about 68 and 120 degrees Fahrenheit, and then they're rapidly killed at 158 degrees Fahrenheit. Any more specific than that, you start to get a little bit of uncertainty. There's a lot of different papers out there that have different values in this range for specifically where things grow and die. But these are pretty good references that we got from New Jersey. So these bacteria can also live inside of biofilms, which means if you're talking about disinfection practices and trying to get rid of a culture that, if you just go through and clean once, that might not be enough because you'll have layers of biofilm that contain Legionella as well. So this is a gram-negative bacterium, and it's pathogenic. Like I mentioned, it causes Legionnaire's disease, which is also known as legionellosis. So the way that you contract Legionella is by inhaling a living bacteria. So it has to be a live bacteria to cause infection, and it lives in water. So when water is aerosolized, it can carry those bacterium into the air where you can breathe it in, it enters your lungs, and then it actually enters human cells, grows and proliferates in there, and then causes subsequent damage. And that's how you get an infection, and now you have Legionnaire's disease. And so the symptoms of that are a fever, cough, chills, muscle aches, and headaches. Basically, it's like really nasty pneumonia. Not that many people contract this every year, and the people who do often have one of these risk factors. So the risk factors for legionellosis include chronic lung disease, being older than about 50 years old, people who are immunocompromised or have a history of smoking, having or having had cancer, or any other sort of underlying illness. One thing I do want to note is that diagnostic tests are limited. So there's like two standard ones. One of them is quicker and faster and more commonly used. But it can be really hard to differentiate between pneumonia and Legionnaire's disease. And often people can kind of assume that it's pneumonia and not even right for a test. So if a doctor's not prescribing this diagnostic test for Legionnaire's disease, it's possible to miss it and misdiagnose as pneumonia. So because of this, it's a little bit difficult to nail down the exact scope of the problem, and there's a little bit of discrepancy about numbers. So the CDC, Centers for Disease Control and Prevention, has national reporting requirements for different diseases and health outcomes that states are required to turn in so that we have a great national database to look at. And they use this surveillance to follow up on outbreaks and to improve prevention and response. So Legionella is one of those reportable diseases. It's a communicable disease, and that's where it's categorized. But states have somewhat different reporting requirements, and they can make the criteria for what they classify as an outbreak by differing standards. And the CDC in 2018 reported that 10,000 cases of Legionellosis were passed on from the states to them. But then OSHA and the National Academies of Science say that there's about 50,000 to 70,000 cases per year that happen in the United States. So either way, we know that all of these numbers aren't fully accurate because the true number of cases is estimated by the current literature to be 2 to 3 times higher. So we're dealing with up to a couple 100,000 cases per year, or but either way, it's not a good disease because regardless of how many people are getting it, people are still getting it, and so that's concerning. And then out of the patients who do have Legionellosis, there's a 10% patient mortality rate, and there's a 25% mortality rate for those who contract Legionnaire's disease in a healthcare facility. So if you've heard of this before, it's probably in the context of a healthcare facility or in travel-related exposure. Legionella was also kind of a hot topic when the first COVID lockdowns were ending, and all the buildings that had been sitting with everybody was working from home, and so all of the water was stagnant in pipes, and so everybody was a little bit concerned that there were going to be Legionella outbreaks when people went back to work. So you might be wondering, if that's the case, how did we get involved? I haven't said anything about wells yet, and we really didn't have this on our radar. I don't have a huge background with bacteria, so this has been a really fun project for me to pull all of my bacteria knowledge back out. And so a while back, Steve was doing a private well class, and somebody asked, is there Legionella in private wells? Should I be concerned about my well? And Steve said, well, that's a really good question. I'm not actually sure. And I said, I'm not sure either. And somebody else who was in attendance actually sent us an article, which I'll show you in just a second. And so we started looking into this and started figuring out that single-family residencies are a potential exposure source, and they can have Legionella colonies. So previous research that has been done on homes that are on the municipal water system indicates that somewhere between 6 and 32% of homes could be colonized. A study was done in Flint, Michigan, after they were starting to rectify the whole lead problem, and they wanted to see if there was Legionella happening as well because they had an outbreak. So they tested a bunch of those homes, and they found that 12% of their homes were colonized with Legionella. And that home plumbing environment is just perfect for a thriving Legionella culture. And then if you're living in that home, potential routes of exposure are showering or dishwashing, clothes washing, humidifiers, CPAP machines, and other respiratory devices, basically anything that's generating an aerosol that then the inhabitants of the home can inhale. So this is the paper that was linked to us when that attendee asked, hey, is there Legionella in private wells? And in 2020, a group of researchers found that yes, actually, Legionella is in private wells in North Carolina, at least. And so this team, led by William Rhodes, who is a colleague who used to be at Virginia Tech and is now at EWAG in Switzerland, went and sampled 44 different homes on private wells in Wake County, North Carolina. And they found that there was a 9 to 15% positivity rate. And so they sampled hot and cold water samples and did multiple methods of analysis, including this IDEX Ledge Alert method, which I'll talk about a little bit later. And this project really emphasized that there are some private well specific issues happening with Legionella exposure, and that it would be worth looking into more. This is an understudied issue, as a lot of private well contamination is. And also, like we've talked about in a few other talks, private wells are unregulated in terms of disinfection practices. So the other stats that we looked at on the previous slide that were suggesting homes had anywhere between 6 and 32% in cultures of Legionella, that was for municipal systems that do have disinfection practices. And so we were curious, how might this translate to private wells in Illinois? if we don't have disinfection practices, will we find it at similar rates to North Carolina? And, let's just start investigating a little bit. So after doing a little bit more research, we found out that those outbreaks that happen in healthcare facilities and travel-related exposures only account for 4% of the cases that are nationally reported to the CDC. So 96% of cases are sporadic, meaning that they're not linked to an outbreak, and often the exposure source is never identified or investigated. So our question going into this, or our goal really was, well, this exposure is happening somewhere. 96% of people, we don't know where they're being exposed. And is it possible that private wells are one of those exposure sources? And we thought we'd go sample some wells, and if we get hits, great, we'll look into it a little bit further. And if not, great, we can probably cross that off the list of exposure sources and see where we go from there. So before we move into the actual results from New Jersey's project and from our project, I do want to take a second to give you a little bit of context in terms of sample analysis and risk, because I don't want to overstate results. So there's two main ways that you test for Legionella in water. So you take your water sample, and then you can either culture it, which is where you test for the actual living infectious bacteria, and then you can get an estimate of how many live in that sample. And the IDEX Leg Alert method is one nice way to do that. That's a pretty standardized, compact kit that you can use, which is pretty handy. And then the other thing you can do is PCR, which is a DNA technique where you test for a piece of DNA, and it can be from a dead bacteria. So if a bacteria has died and passed through this water and leaves behind trace bacteria, you can still get a positive result. And so basically you're sampling your water for a bacteria was here signature. And so when we try to talk about risk in terms of positive results, it's pretty complicated because we don't have an MCL. For other like chemical contaminants, often there's some level that we know is a cutoff, or like we can only have this many, this is regulated to be this many parts per billion, but we don't have that for Legionella. There's no exposure standards or limits, and so having a positive result doesn't necessarily correlate to a specific level of risk, and so then it's hard to tell people if it's dangerous or not. So just keep that in the back of your mind. So New Jersey set out to sample some homes and figure out if private homes exposure could be contributing to some of that sporadic case problems. And they sampled 60 different volunteer homes that represented the 20 highest populated counties in New Jersey. And then they also sampled 40 homes that had known cases of Legionnaire's disease, and they prioritized incident cases. So they took up to 5 samples per home and ended up with 451 total samples that came from various kitchen sinks and bathroom sinks and showers, basement water sources and hot tubs. And these sampling locations are great because those are locations where you would expect some aerosolization and potential inhalation to happen as well. So they analyzed both with the PCR and culturing methods. And then they also measured free chlorine to see that disinfection metric. So on the homes that are on municipal water, they'll have a chlorine residual from that municipal disinfection process. And they wanted to be able to compare that to if there happened to be any chlorine anywhere else and to see if that correlated with Legionella. So what they found is that 2% of homes that had more than or equal to 0.1 milligram per liter of chlorine tested positive for Legionella. The homes that had less than 0.1 milligram of chlorine tested positive 9% of the time. And so what this is saying is essentially that when chlorine doesn't make it to the home plumbing system, there is an opportunity for growth, which is definitely relevant to our private well homes. And then out of those positive results, 30 of the 33 had a chlorine residual or chlorine of less than 0.1 milligram per liter. So then they also compared the positivities of their public water homes versus their private well homes. And they had 18% of their private well homes come back positive. And statistically, that was the same as their public water homes. So those were testing positive at about the same rate. So this is all happening in the background, and I'm trying to figure out, how does Legionella work, and how is it reported to the CDC? And so I started calling states to look at their reporting practices and figure out when they follow up with an investigation, what do they ask? And do they ask if patients who contracted Legionella are on a private water system? And the answer to that preliminary answer is rarely. So most states, when they're doing this investigation and follow-up to get data to hand over to CDC, they don't ask. 3 states, Georgia, Arizona, and Maryland, do. And so we're trying to reach out to those guys and collaborate. We're waiting to hear back from Georgia, and hopefully we'll hear back from Arizona and Maryland sometime soon. And the question we reached out to them with was, can we identify the percent of cases where the patient lives on a private water system in any of these states? And our preliminary answer is that actually we got responses from Wisconsin and New York, and I'll tell you how we got those in a minute, and hopefully we'll get it from Georgia. And then the next question we had starting this project was, will we find Legionella in private wells in Illinois? And if we do, what rate? So preliminary answer is yes, and we'll look at data in a second there. And then our last question was, can we collaborate with other states on this? Because we're new to Legionella, and there are lots of people who are out there already working on it. And the answer to that is a resounding yes. So William Rhodes, who did that private well paper with the Legionella that I showed you earlier, he put us in contact with New York and New Jersey and Nevada and Wisconsin. And we all were able to speak with each other and get some really great advice for Steve and I on how we should progress with our sampling practices and analysis. And so that's been a lot of fun to work on together. So that statewide data that we were able to get from New York and Wisconsin was not particularly easy for them because they didn't have that, they don't immediately ask that question following up like a state like Georgia might. And so New York, when we were talking with them, was like, well, hey, we can probably come up with this number. Let's use GIS. And so GIS is a mapping system where you can plot different layers of information on top of each other. And so they went ahead and defined their entire public water system for the whole state. And then they plotted all of their Legionellosis cases on top of that. So they included data from 2018 to present day. And then they excluded New York City because New York City is going to have a huge bias towards healthcare and travel-related exposures. So they just decided to take that out for simplicity's sake and focus on the rest of the rural state. And so the sample size here was 2,422. And they found that 13% of cases were not linked to the municipal water system. So these are homes that are potentially on private wells. And then Wisconsin actually recently implemented their own statewide supplemental form for their own personal investigations that asks if a home is on municipal water or not. So they had data from that form from 2017 to 2021. And then they were able to remove any cases that had been successfully tied to an outbreak. So anything that would fall under that 4% cases known outbreak. And they took the remaining cases, which was 448. And then found that 30 of those were not on municipal water. And then they saw that 5% of those cases, the patients did not know what their home water source was. So somewhere between 30 and 35% of cases are potentially on a private well. And we're hoping to find this we're hoping to find other states to get this data from, because what this tells us is that it is worthwhile to sample private wells because cases are linked to homes, or the patients do live in homes that are not linked to municipal water. So it'd be good to know if that home water could be a potential cause of their disease. So the sampling project that we've been doing is in collaboration with an ongoing study. Dr. Walt Kelly, Dr. Sarah Geiger, and Dr. Sam Dorovich have been doing this lead and private well study, and I think you guys heard from Walt yesterday on this. And so we reached out to their participants and found 60 volunteers that we recruited to do a bit of a citizen science, and we followed the method that Walt and his team had started. And so we shipped out a kit with all the sampling materials needed and some instructions, and we had the homeowners collect the samples themselves and mail it back to us overnight. And we had them take 3 samples from each home. So they took from, we had them use a bathtub, or if they didn't have a bathtub faucet, we didn't want to mess with the shower head, so they were able to use the least used sink in their home, like a guest bathroom or something. So they took a first draw sample out of the hot water tap, waited till it got warm, took that, and then waited till it got hot and took that sample as well. So we're hopefully defining the home water environment there. And then we sent those 3 samples to the institutional water treatment technology program or technical assistance program that is housed at ISTC here at U of I campus. And they did IDEX ledge alert testing just like William Rhodes's paper did. And so that is, again, that liquid culturing test. So we get an estimate of the amount of bacteria. And so we'll have that for our records, and if we want to do any data analysis down the road with that too. So here are the preliminary results. Out of those 60 homes, we currently have gotten back 34 homes, and the overall positivity rate for them has been 21%. And you'll remember each of those homes had 3 samples. We sampled in triplicate. So I marked a home as positive if at least one of those 3 samples came back positive. If you look at the individual sample results, the overall positivity rate is 13%. So this is saying that not every home had all 3 samples come back positive. There were some homes that only 1 or 2 came back positive, which is interesting, and we're not really sure why yet. And that's probably something we'll investigate a little bit down the line. So we've gotten Champaign County, Kane County, Whiteside County, and Peoria County. We only have 1 from Kane so far, and that one did come back positive. And then the other counties, Whiteside and Champaign, both had a 20% positivity rate, and Peoria had a 12.5, which is overall we get that 21%. So yeah, that's where we are right now, and we're waiting for the rest of those samples to come in. There's another batch that went in this Monday and are in the incubator now, so I'll have those results next week. And then we'll get a few more in the mail this coming week as well. So we really wanted to just share this with you guys today. I know it's still preliminary results, but it is possible that private water systems are a source of Legionella exposure, and we're pretty excited about this project. And so we wanted to put it on your radar while we're all here together. The next steps for us are to finish analyzing those samples, and then we'll work to communicate the results to the participants. This is one of the things we're working with the other states to figure out exactly how to do. We're considering different recommendations and possible homeowner actions, because you don't want to go to your homeowners and say, well, you have Legionella, it could cause Legionellosis, but have a good day. And so we're trying to figure out what to tell them. And also it's that idea I was talking about before with risk. You don't want to overstate risk, because, you know, if you have, if you're a high risk person, then perhaps your level is concerning. But if not, you know, it might just be that you have a handful of bacteria that would never actually cause an infection in real life. And so figuring out how to handle that level of information and figure out what sort of recommendations we want to make is a little bit tricky, and we're still working on all of that. We're also considering gathering some additional data from different private water systems, so potentially expanding sampling across the state or collaborating with other states. And then eventually we'll probably write up 2 papers. We'll do one on the sampling results and these the result of analyzing everything, and then probably a separate paper on what I've done with calling the states and asking about their investigation practices and that percent positivity rates and what homes are on what systems. So look for those eventually. And then as we've been talking with New York, New Jersey, and Nevada, we are kind of toying with the idea of doing a private water systems workshop. So still in discussion, but I think we're hoping to do that this fall. And if we'd love to see you guys there, if you'd like to come, we'll cover everything and anything Legionella related, and especially private water related. That is all I have for you today. I would love to answer any questions that you have, and I'll throw up a couple of references here in case any of you are dying to read academic papers on Legionella.
All right, thanks, Natalie. Yeah, and Jessie is actually here. She just commented. And I would say that what we've discussed with them, with New Jersey, Nevada, and New York, is having a chance for them to present all of their results as well. They've really helped us out a lot, as Natalie mentioned. So it's been a great relationship so far, and yeah. We don't have, someone commented about CPAP machines.
Yeah, I see a couple of questions. Katie, I saw your comment. I was wondering that too. Was it named because it was an American Legion outbreak? I feel like it must have been.
So it wasn't an American Legion. It was an American Legion conference in Philadelphia
Yeah.
at a hotel in Philadelphia in 1976, and it's why it's called Legionnaire's disease, is what I understand. So, and
yeah, it was a conference, not an actual. Yeah.
it wasn't an American Legion. It was a hotel in Philadelphia. Yeah.
And I think too that I was thinking about this. That's probably why things got set up to be so focused on outbreaks. And we always talk about Legionella in terms of outbreaks. And I mean, if it was identified because of a big outbreak scenario, that makes sense. And kind of now we're taking a step back and realizing that it's a little bit sporadic too. Sporadic.
I missed Jesse's comment too, is that Remind Me in New Jersey can share estimates of LD cases on private wells.
Ooh, thanks, Jesse.
Yeah, that's we were really surprised with the number in Wisconsin, 30%. It's a smaller sample size, and again, New York really went out of their way to GIS map all of their cases and provide an estimate. So, it certainly seems likely that private wells. And homes on private wells. It's not actually the private well. It's in the home, in the lines that cause those issues.
Mm-hmm. Danielle, I see your comment about CPAPs. I know a lot of people who have those too. It would be interesting to see how many people live on a private well. And I know that you're supposed to use distilled water, but I also know that buying that can be a pain in the butt. And if you're trying to go to bed and you're out of water, then a lot of people do end up using their tap water. So that's an interesting public health area that maybe we can look into.
All right, so here's another question. Did you collect other water quality parameters, hot water temp, iron levels, coliform analyses that may indicate soil intrusion, etc.?
You want to take that one, Steve, or you want me to?
I can. So we didn't collect any other water quality parameters for our part of the project, but as Natalie mentioned, we piggybacked on Walt Kelly's and colleagues' lead study and contacted the same folks that were already participating in that project. And so they did collect analysis. We're still in the middle of our sampling, so I don't think either one of us have actually looked at everything they did collect, but it certainly won't include hot water temp.
And we don't have coliform analysis too. I think that... Yeah, I don't think we'll do a ton of data comparisons between other water quality parameters on this round. I think the primary goal here was just to kind of, is it even worth investigating further? Are we going to find any at all? And so now that we're seeing, yes, we're having potentially 21% of our private wells coming back positive, other water quality parameters are definitely something we would look at in the future.
And as she mentioned, we're really getting our feet wet. And this started, in February of 2021. Someone asked a question on one of our webinars. And as we started looking into it, we found, they'd mentioned that paper. And it's been a process since then to get where we're at today. And so this was more of an exploratory project to see what we find. And then we'll work with our colleagues and seek advice and try to come up with a way to do some additional work. This was funded through a state of Illinois program, the Hazardous Waste Research Fund. And so it's sort of internal funding, it's state of Illinois money. And anything now, we want to use this information to expand that if we can. And that's where we're at, or where we will be in a few months. Okay, so there's a comment here from Marty. Some of the cases in Wisconsin were at vacation home rentals where water is sitting in water heaters at temperatures under 120 degrees, certainly.
Yeah.
And so I'm sure that's the case. And it is, that's why they have shut down and startup procedures for non-community systems. And we try to recommend that to private well owners who have a second home, that you should disinfect before you do anything. And there's a lot of issues where folks don't think it's a big deal to leave their water sit for 6 months or 4 months and then just start using it. And it's really, you're really at risk for biofilm buildup and things like Legionella and all those issues.
Yeah. Eric, thanks for that article. I'll have to take a look at that, and interested to hear what classes you're teaching too. And Marty, I think that if we get to keep working with this data, there's a lot of things like whether or not it's a vacation home and what that water heater temperature is that would be really interesting. And I think that all answers slightly different questions and would slightly change how we inform our advice or how we advise people, and what homeowners need to be aware of versus like if you're renting a vacation home, like should you be aware and maybe go flush your water at your vacation home before you go taking a shower or something like that.
All right. Well, thank you. Yeah, interesting stuff. Something that you don't hear. We work on the small water system side too, as I mentioned, through wateroperator.org. You hear about Legionella, as Natalie mentioned, in the cases of the building startups, hotels, all those sorts of things, nursing homes or veterans homes, and it's just played down that it could be an issue for homes on private wells or even homes in residential areas as a much less risk, just because what all the larger players like CDC are looking at are outbreaks.
Yeah.
And I was really shocked to find out that 96% of the cases are actually sporadic.
Yeah.
It's really, it really shocks me that it hasn't been looked at that closely. And maybe it has, and I just haven't found the information. But all right, thanks. Great job, Natalie.